So, in the previous lesson we have talked about the iterable class in Python programming language, and we will continue with some other examples. Firstly, we can import the math library in here like this one, and so the class sqrt iterable can be defined in here with the init function, and we should give also the limit body in here. Okay, self limit is equal to the limit, and so we will define the iterable class with the one values and its sqrt square root values in here. Okay, and so if this is the definition, and then we can give the iter with the parameters or the return values of the sqrt iterable is changed with the iterator. Okay, and self limit is assigned with this parameter. And so how about this sqrt iterator implementation in here? And so sqrt iterator def init can be given like this one. Self limit is equal to the limit, and self I is a specific index for the constructor. Okay, and after that we can define the def iter self, and self I is equal 0, and return self is assigned like this one, and def next body self if self I is equal to the self limit like this one, and so raise stop iterator can be thrown. Okay, and after that the self I must be increased with the 1, and we can return to the math sqrt function self I can be given in here. Okay, and so s can be defined sqrt iterable with the value of 25, and after that the for f in s, which is the iter and the next function are called within this for loop. Okay, and so the print f can be called like this one, and then the 1 and like this one, the 10 dot blah blah blah, and 5 is assigned in here like this one. Okay, in this term we can generate in an iterable form, or at each iteration we can calculate the square roots of the for a given body or the values. Okay, so by using this notation we can derive the random class with the iteration formulation. Okay, for example, we have the random class or this library, but we can define our own class or random operation with the names of the simple random. Okay, and so we can give the def init body in here like this one with the self, and so self seed can be assigned with the integer conversion in here like this one, and time can be called times 1000, which is the milliseconds. Okay, this is the seed value. At each time this seed value, or at each run, is different because the time is changed at each time. Okay, and so we can define our private function in here, generate next seed. Okay, which means that we can create the simple pseudo random number generator. Okay, And so this self seed is assigned with the what? This is the constructor of the R values, but at each next operation we can set the different seed value with the what? Self seed times 1 1 3 5 5 2 4 5 1 2 3 4 5. This is an arbitrary number, but 0x7 f. Okay, this is the simple syntax for the what for R notation. Okay, the seed at each iteration is different. Okay, because at each time different constructor is used, but this can be changed by using the what another formula. But this is what I want or what I choose. Okay, and so the random integer number generator can be defined with what the self, low and high value, like in the what which is given the import random library. Okay, and so if low is greater than high and raise the what the value error. Low cannot be greater than high. This is the syntax error or the runtime error. But this is not the case. We can assign the values with what the self, generate the next seed values, percentage high minus low plus 1, which means that the lowest value, for example the 1, highest 6, and then at each iteration we can generate the new values in here, but with the what the return value plus low. Okay, so this is the case of the what definition of the random integer generator. This is just like the what the random library definition. Okay, but we need to add the another property, rand iterable function body, in here, like this one. For example, def init and self a, b and c should be given in here. Self a is equal a, self b is equal to b, self c is equal to c. Okay, and after that we need to give the what another term, simple random generator, with what the simple random constructor. Okay, and after that we should give the def iter function in here, like this one. Def iter self count is equal to 0 and return self should be given, and next must be defined in here. Self count is equal to the self c, which is the highest value, and raise stop iteration. Okay, and self count must be plus equal 1. Okay, at the end of this code we need to give the self simple random and rand int function with the what parameters of self a and self b. Okay, so if this is the case, we can give the L a list rand iterable number with the what the 10 to 20 with the 5 values. Okay, and so 5 different numbers within the range of the what the 10 to 20. Okay, and so we can print the what the L like this one, and so if we rerun this code, and we have always different number because the seed is different from each other. Okay, or for I in rand iterable with what 0 to 10 or 110, and we can print the what I and like this one, and so we have the what the different or random number between or the in the range of the what the 0 to 100. Okay, or we have the another property for the what the rand iterable function, which means that we have built to what the try and catch or exception block in here, and re random integer number can be assigned with the what, the 0 to 110 values, okay? And iter is also defined with the what, the iter function body. Which means that this is the what, the basic constructor for the what, the iterable objects at this case. And after that we can define the endless loop in here like this one. The I is iter dot next function can be called, which means that we generate to the what, to the different number for the different seeds, okay? After that we can give the what, I and these terms, okay? After that, except we can call the pass, okay? And so at each iteration we can generate these terms, okay? And so this for loop is identical with this one, okay? And so this is what the first conditions for the what, the index operation in the iterable objects. But in the every case of the iter.next creates to the what, the different form of random number with the return values of this one, okay? Any question? In Python programming language we have the standard or built-in function or the libraries, but in this case we have these generations, okay, or these examples in here. So the standard library has kind of features like we implemented it, okay? So in the next iteration we can also create the range body in here. Range is a built-in function or built-in class in here, and for I in R can be assigned with what, the print I and with the what, these terms, okay? And so 0 to 9 is written in this case. But what happens if I try to what, the R range assigned with the 10, okay? And so iter is equal to the R iter function in here, because the iter should be defined in the range function because it's iterable class, okay? And so we can define the try true values in here, and I is equal to the iter next body in here, and after that the print I and end is assigned with the what, these terms. And so except the stop iteration can be called in here, and we can get this pass operation in here, okay? And after that if we run this code, and then these two terms are identical with each other, okay? But this is what, this is the expansion form of the range implementation for a given the for loop in here like this one, okay? So what about the R range function? In the standard library we can use the range function, but we can also create the my range body or class in here like this one. Firstly we need to give the init function body, and self and start and stop is equal to the none, and step is equal to the 1. And so this may not be necessary, stop and stop step value, but the starts must be given for the what, for creating the stop values, okay? And so firstly we need to check the what, the step is not equal to the 0, but if this is the case we should throw the value error in here. And after that if stop is equal to the none, which means that we don't have any parameters for a given what stop, and then the self start is initialized with the 0 value, and self stop value is assigned with the what, the start, because the self start should be given or started with the what, the 0 values, but the stop values must be equal to the what, to start values, okay? But this is not the case, and then the self start should be assigned with the start, and self stop should be assigned with the stop, okay? And at each case self step should be given like this one, okay? After that, we need to give the def iter body, which is this is the constructor of the iterable objects or the parameters in our cases. Okay, and so this iter should be given in the self I must be given with the self start because it's the starting point, and return self should be given in here. And also we need to give the def next body in here like this one, and then this next should be get the self parameter if self I is equal to the self stop, and then raise stop iteration exception throwing, and self I must be increased with the what, with not the one, with the step number at this case. And after that we need to give the return self I minus 1. Okay, and so my range can be defined 1, 50 and 7. Okay, 7 is the step number, and the 50 the last number, 1 the start number. Okay, and so for I in R, print I and like this one. Okay, and so 7, 14 blah 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 49. Okay, and also we can give the another terms like this one. For example, if we remove these terms and then 1 to 49 values is written. Okay, or we can give the 12 value in here like this one, and then we have the error in here because this values step number is assigned with these terms, and self I must be getting in these terms, which means that we have the 9 value in here, or we have the 7 value in here like this one, or we have the 2 value in here like this one, and so we have the endless loop in here like this one. But at each iteration we have this notation. Okay, because the self I is not equal to the self stop in here. Okay, these parameters must be updated with the another term in here. For example, the self step self I, which is equal to these terms like this one, but the true case which is given in this formation. Okay, see 50 values or 12 values like this one, or 24 values like this one. Okay, but in this case we have the 72 because the self I and self stop is not in this case. Okay, and so we need to also give the this term also. Okay, so this is the last code for the range function body in our lesson. Now we will continue with the sqrt function or the another sqrt function f8 and f9. By using this information we can also give the import math parameter in here, and class sqrt iterable can be defined with the definition of the def init, and self and limit should be given in here, and self limit is equal to the limit. Okay, and after that the def iter self body self I must be equal to 0, and return self value can be given, and also next can be defined with the self I is equal to the self limit, which is the index values of our case, and raise stop iteration should be calling it right now, and self I plus equal 1 and return self I must be given as a tuple values in here, and square root value should be calculated at this case. Okay, so s is equal to the sqrt iterable, işte only class s, and print I, and value is given in here. Okay, this is stored in the what 25, and the square root of these terms is equal to the what the 5. Okay, so this station or the next and iter operator can be defined or used in our language by using these terms. Okay, after that we have the one form in this code notation, which means that we have the for I in reversed function with the what the range operation in here, and so we can print the what the I is equal to the end, and so we have 9, 8, 7 blah 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 and 0 values. Okay, and so how can we implement the reverse method in the what in our iterable objects? It's simple. Class my range can also be defined in here like this one, the init body with what the self and start and stop none, and step is default values equal to the 1, and so if step values equal to the 0 and raise value error. Okay, if stop is equal to the none and self start is equal to 0 and self stop is equal to start, but this is not the case. Self start is equal to the start, self stop is equal to the stop. Okay, and after that the self step should be assigned with the what the step parameters. Okay, so in this notation we can define the def iter function, self and self I is equal to the self start, and return self should be given in here, and also we can define one more another underscore double underscore function, a reversed function. If we use this reversed one function, we can return the what the my range reverse iterator, self start, self stop and self step values. Okay, because in this case the iter always increasing, not the decreasing values. Okay, but in the reverse order we should implement or define the new class variable to what to create this effect. Okay, but we should also give the def next body in here like this one, the self if self I is equal to self stop, which means that the our case is stopped, and raise stop iteration should be called, and self I minus equal as the self step, and we should give the what the return self I minus 1. Okay, and so how about the my range class, my range reverse iterator, def init self start stop and step values, and self start should be defined with the start, self stop stop, self step step, and also we should give the self I is equal to the what the stop, because it's the reverse operation, and so the first term should be equalized to the what to the stop values. Okay, and after that we should give the iter constructor in here like this one, the iter self, and return self can be assigned because the self I is assigned with the what within the constructor. Okay, and so def next self if self I is equal 0 and raise stop iteration and self I minus equal 1 and return self I. Okay, so what about this notation? Range is equal to the 10 and print I end. This is the direct increment in the what? In the range operation. 9, 8, 7, blah blah blah, and 0, 1, 2, blah blah blah. But in our cases, for I in reversed my range like this one, the print I end is calling in here, and then we will get the same results like this one. This is the reverse order of the what? 10 to 0 values. Okay, so this reversed can be defined with the what? With two class, but the one class is called with another one. But this is the reverse is special function like the iter or next. And so if we have this property, we can define or we can write the whole data by using in the what? In the reverse order. Okay, so any question? Okay, it's the end of the lesson, and so in Friday we will start with the OpenCV examples and how we can handle the OpenCV in a Python programming language in a video stream, or the picture analyze, or the cropping, rotating any image, or taking from YouTube to a video in our computer. We will talk about it in Friday. Okay.